I saw you on Twitch like maybe like a week ago, a week or two ago, and I was like, hey, I recognize that person. Yeah, exciting to see you starting to stream. Is that something you're getting into?
Yeah, so I actually did. I think my first venture into Twitch was in 2018 for Advent of Code.
Hmm.
And I did that for a while and it
Nice.
was nice. But I never really I think this is probably like my biggest streak. And I think like part the reason why is because I spend today a lot of time like reviewing people's codes and like there's the company, it's a small company, we're not even 10 people, but I'm spending less time coding.
Hmm.
And actually like the most time I spend coding nowadays is when I'm twitching because I can just like sit, I'll be like, I'll sit here and I'll code with everybody, but it's just for coding.
Yeah, it's funny because people have very different experiences. Like some of the people that I know that stream, this is when they get the least amount of work done because they're just so distracted by the chat and like by people watching. But it's pretty productive for me as well. It's similar. Like I have so much that I do. Like I'm juggling a bunch of different things. So
It's funny because the projects that I was working on so far, I probably already streamed like 10 days. And in the, only did Elixir for real, like in the 80th or 90th day. So all the time before. First, I was trying to do something with ChatGPT. So it was
mhm.
basically prompt engineering. And then it was Rust and a little bit of C. So it was fun like because those are not things that I have experienced, so it was
Mhm.
actually helpful doing that with everybody because people who actually know Rust and actually know C, they were helping out. I at some point I was even joking that it was like the equivalent of Twitch plays Pokemon but for programming because I was just hearing what people say and they're like, okay, I'll try this, I'll try that.
It is awesome when you have a decent sized audience and there's people in there that know stuff better than you. It's like that combined with ChatGPT, it's like a superpower. It's just you're just like a body that other people are controlling. Yeah, just for a little bit of context, I for the past I guess 2 to 3 years, I've been in the serverless space, and specifically that's brought me to backend JavaScript, and everything I've been doing has been in backend JavaScript. And most people know me from that, but I'm still relatively new to it because I was spending the previous 4 to 5 years in the Elixir world. And as someone coming from another ecosystem into the JavaScript world, I think I just have a different perspective on like just the type of tools I'm used to, the things that I had available before that I no longer do. So I've been trying to talk to more people that are from other ecosystems. Like I had someone on from the Laravel ecosystem a few months ago because I think the JavaScript backend world, I feel like the bar is very low in terms of what is considered like, okay, these are good tools. But I think that's mostly because most of the people in that ecosystem just haven't seen kind of what's available in others. So just getting more exposure to the other stuff that's out there, I think will help make the JavaScript ecosystem better. I just feel like it's not that there's any technical limitation. It's almost like a cultural thing. Like we don't know that we can make stuff better. And I feel like we don't look outside of our bubble as much. So yeah, I was excited to talk to you. And I have a bunch of questions and we'll just kind of run through them and it'll be a casual conversation. I talked to you because, you bootstrapped a new ecosystem from zero, like roughly zero. So I think there's a lot of interesting insight and hearing about that journey and the kind of specific details there. Does that make sense?
Perfect.
Cool. Jose created a language called Elixir. When was that? Like 13 years ago? Something like that?
12, almost 13, yeah.
Yeah.
The initial prototype it was like 12, 13 years ago, but the version that became Elixir today was 11 to 12, was a year later, kind of.
Nice. Yeah. So I want to hear like, how did that even happen? Right. Because creating people create new frameworks and that's like a little bit more common and you've heard of that. But that's usually sitting on top of an existing language and ecosystem. But so creating a brand new language, how did that happen? What gave you the confidence that it was viable? Because like, creating the language seems like a lot of work. Like a lot of things needs to happen before it's even adopted or gets traction. So yeah, I would love to hear about that journey.
So always started. So before I worked on Elixir, I was a member of the Rails framework, the Rails framework core team. And even back then, we were starting to hear a lot about concurrency.
Hmm.
Like we were starting to get like the first machines with multiple cores, and then people wanted to deploy those things using all the cores in the machine, but it was not really feasible. And we were working and improving those things over time. And today, I like to say that like everything that you do in your machine, it should be using all cores,
Hmm.
right? Like because even your wristwatch today it have like 2 or 4 cores, right? So we say a lot, oh, like something is slow, this tool is slow, like and then you look at it, my tasks are running slow, and then when you look at it, it's just using 1 core in your machine, which so there is a chance that things can get like 4 times faster. The resources are there, but for some reason we are not using it. So, but that so back then, that's when it was starting. And I remember there was one bug report that I still remember because it was like, I think it was very significant for me because somebody said, look, we are running Rails in production. And when we have a spike in traffic, so a lot of people are using at the same time, they have auto scaling. So auto scaling would start a new instance of Rails. And when that new instance was booting, it would get errors that were booting. Somewhere in Rails boot process, things were failing when there were many requests at the same time. And then when you get a bug report like this, like your first thing is like, how I'm even going to reproduce this, right? Because it's like such a specific
Hmm.
scenario. And it's related to concurrency. It means that when Rails is initializing, requests are coming in, there's something happening somewhere about 2 requests coming at the same time that makes things fail. So like how I'm going to reproduce it, how I'm going to tackle this, how I'm going to fix this. And even if I do all those things, like how can I be sure that I tested and fixed it properly? So that was kind of like one of the things that made me think, if concurrency, so running software on all the cores in your machine as efficiently as possible, is going to become an important thing, I need to have better tools. So it always started for me as like trying to find better tools for the problems that I was
Hmm.
facing, which I think really resonates like with what you were saying at the beginning of always like trying to look outside. And that's how I started doing. And then so I put myself in this journey, and I like to say that there were 2 points in this journey for that like changed how I approach software. And the first one is functional programming, and it means a lot of things to different people. But to me, what it means is that if you get a lot of the concurrency issues that you have in OO or imperative languages, is that so for example in that case I would have like 2 requests or 2 threads trying to change the same place in memory. So try to mutate an object or something like that. And then because they were trying to do at the same time, something would get corrupted. If you're lucky, you get exception. If you're unlucky, you get a segmentation fault, and the
Hmm.
whole thing crashes. And the thing about functional programming, and again, it means different things to people, but to me, it's really about instead of changing things in memory, we always transform things. So if I have a list with 10 elements, I want to delete one. Now I get a list with 9 elements, and we have ways of making that efficient. But for me, like this was like a big change because there are ways that we can solve problems, and sometimes you solve a problem by putting a tape on top. But if you can solve the problem by removing the problem altogether, then it sounds like very exciting. So I was like, okay, this is great, and I want to learn more about this thing. Like I was convinced, and it would also help with a lot of like sometimes when you're writing code, in the usual languages like JavaScript, Java, Python, C, right? Like when you call a method, for example, you pass something to that, and that thing can change the arguments in
Hmm.
ways that you don't expect because you can always change anything. So, and I was like, well, that problem is also removed. Everything's going to be more explicit about how data goes in, how data comes back. So for me, it was an easy sell. And I was like, okay, I want to learn more. And then I started learning more about functional programming languages, functional runtimes, and eventually I found the Erlang virtual machine. So Elixir runs on the Erlang virtual machine. And the Erlang virtual machine was designed by Ericsson, which is a telecommunication company. And what is really interesting is that if we go back like 11, 12 years ago, like everybody was talking about concurrency. It
Hmm.
was in everybody's radar. So if you see like the programming languages that were coming out at the time, like Go, Clojure, they all had a concurrency story to them, right? But Erlang did not only have a concurrency story, because concurrency is about, well, I want to use all the resources, all the cores in my machine as efficiently as possible. But if you're working on a problem, eventually, like if that problem starts to grow, you cannot solve that problem only using a single machine. You have to use multiple machines, right? And Erlang not only did concurrency, but it also did the next step.
Hmm.
It did the distribution things and how you coordinate work across multiple machines. So and it not and it did that like 3 decades ago.
Yeah.
So for me, I was amazed. I was like, not only it has solved the next problem, it was one step ahead, but it is one step ahead for like 3 decades. So I really fell in love with the Erlang virtual machine. And at the beginning, I was like, okay, I want to learn more about Erlang virtual machine. So I need a project. I
Mm.
am a impatient learner. I like, if you give me a book, I read 10 pages and I want to do something, and then I
Yeah.
drop the book. So I was like, I need something to do. And I was like, I'll try to create a programming language. I don't have a CS background. So I was like, I'm going to learn two things at once, or maybe learn nothing at once. But I was like, okay, I'll create a programming language. I'll learn Erlang. And after I did that with time, I felt like, hey, I think there's really an opportunity for something here, for a programming language that exposes the Erlang virtual machine in different ways, and that solves those problems that the Erlang virtual machine again has been solving for a really long time. And just one more thing related to this is that the web with time has become really, really closer to like telecommunication systems, because
Right.
with telecommunication system, everything is connected and information is going and coming back all the time, right? And that's what is the web today. We are connected to our phones, information comes, goes. We have IoT devices, so it's a lot of data going through. And I thought like this technology is going to be fantastic for that. And that's pretty much
Yeah.
that's pretty much the summarized version.
No, that makes sense. Yeah, it's funny because I haven't thought about this stuff in a little while, and it's reminding me of a few things on my own. So my dad's actually a software engineer. Like years ago, he mentioned Erlang to me, and he was like, "You should go look at Erlang." At the time, I didn't understand why. Like, I didn't get it. But I remember him saying specifically that the functional programming model, and specifically the actor model that's in Erlang, the model that you apply to make sure that it works across multiple cores in a single machine is that same exact model works whether the two cores are on the same machine or on different machines. And at the time, like again, like distributed systems weren't as common. And he was like, we've moved from one core to multiple cores. The inevitable next step is distributing work across multiple servers. And stuff like Erlang and functional programming are going to be very useful in that era. At the time, I was like, okay, sounds good. And I didn't I didn't understand any of it really. It didn't click for me. But I came back years later, especially when I found Elixir, and I was like, okay, I remember Erlang. I remember my dad talking about it in like a very positive way, and Elixir seems like a nice modern way to address it. And for me, the concurrency thing you talked about is what drew me as well. I originally had been doing stuff in C Sharp. I needed like a better concurrency model. At the time, Go was kind of sitting right there. Like you said, Go came out with like very intentional concurrency baked in. And we built this, we're working on like a distributed data system at that time. And there was an update to Go that made it would panic when you did concurrent map access, which it wasn't doing before. And we updated and we realized, wow, we have a ton of bugs in our system that we didn't know. So at that point, we were like, we can keep fighting with this, or we can rethink, like you said, we can remove the problem. That's when I found Elixir, Erlang, and it all clicked together. It's okay, this whole class of problems of two things accessing the same piece of data, entirely gone in this model, and you can still do everything. And actually, that's just one of the many things that it simplifies. So yeah, I think you made a good point that functional programming means a lot of things to a lot of people, and there's like a spectrum of what that means. But for me, it's you think in this way where everything's actually just simpler. It maybe takes a little while to like unlearn the way you used to think, but once your brain switches over, it's actually a very simple model. Everything's very predictable, behaves in a way that you expect. And what I loved about Elixir was, unlike other functional programming languages, I think back then people typically thought of like Haskell or like, these more esoteric things. it was such a nice introduction to thinking this way, because you need to go through that initial phase of rewiring your brain. But the step from going from whether you're a Go programmer or an Elixir programmer, very easy transition, and you use it for a couple months and your brain is rewired at that point. You start to think functionally by default. And that means like a lot of things. And like, you know, like you said, you think about immutability, but also things like recursion becomes like a lot more natural thing in your head. It like came out at such a good, important time, at least for myself. So the other thing I was going to
Do you
ask is,
remember when it was?
so I think 2015 for me, 2014, 15,
No,
something like that.
that is early.
Oh
It
yeah.
was just about 1.0, so
Yeah.
you were early.
So
Yeah, yeah.
I think I got into it right when Elixir in Action got published, or like,
Yeah, super early.
yeah, okay.
Yeah.
So I guess that is relatively
That's
early.
nice.
Yeah. So, and again, I remember when I brought it to my team, they were like, "Oh, again, you're bringing us like another new thing that we got to learn," and they were, and no one was that excited at first. But and I remember a specific person who wasn't very excited, and you know, he gave it a shot, and he ended up falling in love with it. And to this day, he's now started a new company. Tons of engineers work there, 100% Elixir, and it's been, I don't know,
Nice.
almost 10 years now, and is really stuck with it.
You know what is cool from what you said? Like like your father said, like, if we went from concurrency, went to distribution. What is really interesting is that Erlang went the opposite way,
Mhm.
because when Erlang was created, multi-core wasn't
Right,
really a thing.
right,
So they did a distribution, right? And then when they had to think about multi-core, they're like, oh, we got it.
yeah,
This is fine, right? Like it
yeah,
just works. And I think it's like one of the, when you read and you learn more about how Erlang was created, in that, like, everything they were doing was really pragmatic, in the
hmm,
sense that they were trying to solve a problem, which is to build like telephone switches and this kind of applications. They did not say like, we want functional programming, we
hmm,
want distribution, we want actors. They were not thinking about this. They were thinking like, what are going to be the best abstractions for us to solve those problems that we have at hand, and all the decisions derived from that. And for me, like, it's so interesting and so exciting, right? Like, to take such an a problem driven approach, like, to design a programming language.
yeah. It's that whole bottom up versus top down thing. Like when you start at the bottom and like solutions emerge, you end up with something a lot more resilient. And yeah, that point you made is great. It's like, you know, you really know when it's a fantastic abstraction when an entirely new problem comes up and your model just works. You like, you know, you've discovered something that makes a lot of sense. So when you actually ended up, you said it was like a project to learn. At some point, you must have realized, like you said, this could be a lot bigger. It's gonna be very useful. At what point did you feel like, okay, like I can actually make a language that can be somewhat like adopted? Did that feel impossible? Like, because that seems like such like an impossibility today. So imagine starting there. It must have felt
Yeah.
like, does it even make sense that I'm doing this?
So what happened is that I built this prototype, and it was really bad in many ways, but it was a really learning opportunity. So, like, the first Elixir version, and if you go back in the Git history, it was actually object oriented,
Mm,
because that was the background I had.
right.
And one of the things that I learned with this prototype was pretty much like, Erlang did many of the decisions correct, so I
Mhm.
should just do what Erlang is doing and try to extend on the parts where I feel it's lacking. That was like the big lesson from this prototype. And then I worked on this prototype for like 3 or 4 months, and then I was not happy with the result, and I stayed like the rest of the year. It started in January, then the rest of the year I was like, I did not touch it. But the idea was there in my head. I was thinking like about the problems, how I would solve those problems, looking at other ecosystems. And then at some point I thought, hey, no, I think we can create something. I think, and the value was always there in the Erlang virtual machine. To me, it was always clear, like, the value is the Erlang virtual machine. And I thought, wait, I think we have an opportunity to create a language that is going to provide certain characteristics. And it's a gap that is not filled in today. So what I remember, I told, like, I had a consultancy with some partners at the time.
Hmm.
Well, I remember what I told them is that if the future is really concurrent, and we were using mostly Ruby at the time. And then we say that, and I think the future today is concurrent. And if we for some reason we think that Ruby is not enough, I told them, what is the which language would we migrate to?
Mm,
And I told them it would be Clojure. I think it was the language that at the time most resonated with our practices of like being productive, being expressive, and Clojure brought the concurrency story. But I said, like, like for better or for worse, it's like I don't want to rely only on a single option. So, for
mhm.
example, me as a Ruby developer, way back in 2006, 2007, I always thought like I have assembly, it's Python. Like if I want to try something out, like something goes wrong with this, I have a bolt to jump into
Right.
and felt Python. And then I felt like it feels like if we have only a single option, I don't think that's good. I would like to have more options just in the general sense. And I would like to have an option that is not the JVM for whatever reason. And I think we can try creating this option. And that's when they said, okay, you can work on Elixir part-time. So at that point I was working on Elixir part-time, but I knew and I told them, like, look, I can work on this for like 2 years and nothing may come out of it. It will be like we'll have to close down the project. There is no like adoption,
Right.
and it's basically 2 years of my time and opportunity cost that is going to go down the drain. And this led to a couple things. So one of them is, again, like if you look at the languages at the time, Microsoft with F Sharp,
Mhm.
Apple came with Swift later, and then Google Go. Like if you look at the competition, it's like, well, we were a 30-person
Right.
company in Brazil, right? And those are literally like the richest companies in the planet.
Right.
So one of the things that we thought is like, whatever we do, it needs to be decentralized.
Mm,
Like we are not going to try to say we organize the events, we are the Elixir company. We always said like we want to. For us, the value was always in growing the cake instead of
right.
having like we would rather have a small slice of a big cake than the like
Right.
have a whole small cake.
Right.
So everything is going to be decentralized. You're always going to let and that reflected in the language is an extensible language that people can get and extend it to new domains. This is something we can talk about later. But we had this decentralized approach, and I was always prepared psychologically, like this may fail.
Mhm.
And this was good because it kind of like isolated me. I didn't want to do design decisions based on adoption or popularity. I wanted, if I felt that something is right or wrong, that decision needs to be isolated from necessarily like the feedback that
Right.
this sort of feedback is important, but you want to decouple from if you are failing or succeeding. People say like, have you ever expected this? And then my answer is, I haven't, but I also, by design, I didn't put too much thought into this. I
Mhm.
never thought about where we would go into. Like, I am extremely happy that I was able to, my work was to work on an open source project and create a programming language. And that for me was enough. And I would do my best to foster the community, to foster the ecosystem. But I would not set goals or expectations.
Right.
But there were moments where it was like, you get like the thing was like, oh, like, like things are happening. So I think when Dave Thomas, who was really known programmer, when he said that he's going to write a book on Elixir, within a week, St. Laurent from O'Reilly, who was an editor at O'Reilly, he said he was going to write a book as well. So there were like 2 books announced
Nice.
within a week. So that was like, that's nice.
Yeah.
And then we have like the first Elixir Conf. So those were like really nice, like I think achievements that said like, hey, like I guess other people are is going to use it, and maybe we'll still die, but we're not going to die like next year, maybe in 3 years, right?
Right. Willingness to say this can turn to nothing is pretty important because, especially early on in the project, even if you get adoption, it might be like localized adoption, where if you just end up stuck focusing on that group, that might prevent you from actually becoming, like you said, making the cake bigger. So willing to like kind of kill your own ideas to like make sure that it gets to where it needs to get to. It's something that we think about a lot. And it is tough because oftentimes your early adopters or your most loyal, the version of what they want you to build is not necessarily the thing that makes it much bigger, right? So it's always a tricky thing to juggle.
Yeah, and it's And even thinking about that, just to give some ideas of the numbers, like I started working part time on it in 2012.
Mhm.
At some point, especially when the first books were announced, I think I became full time. And we would have our first client, the first time the company made money from Elixir was like 2016, like
Oh,
four
wow.
years later.
Wow.
And for us to kind of say the project can support itself. So, it's not like we are paying back. We are not like a cost center.
Yeah.
It was 6 years later.
Okay.
So, it's really a lot like a long period of time and like a long-term investment.
Yeah, almost every project I've seen, because I think when most people discover a framework or a language, it looks pretty like complete by the time they discover it. So it feels like, oh, this is a new thing I found. It must not be that old. But almost every time you like look into how long people have been working on it, it is always much, much longer than you expect. Because getting this stuff right takes a lot of time. And I'm sure there was like different flavors of what you built that you abandoned and kind of like went a different direction. The other thing that I was curious about is, so you said at one point is object oriented. You came from the Ruby background. Elixir today just has modules and functions, and this is something I talk a lot about in the JavaScript world. In that you feel like you might need a lot more than that, but functions organized into groups of modules, that's really all you need. You can do everything you possibly need to with that. Was there like a moment where that clicked for you, or like, do you have any thoughts on that pattern?
Yeah, so going back to history, right? So when I thought that Elixir needed objects, and the reason why it was oriented, what I really wanted, and I did not know at the time, is that I wanted dynamic dispatching.
Mm,
So I wanted to say, so for example, hey, I want to have some sort of contract, like, oh, I want to convert this data structure to protobufs, for
mhm,
example. You need to be able to specify contracts, and you want things to obey those contracts. In object-oriented languages, especially the dynamic ones, that's a matter of calling a method. You say,
mhm.
look, if this thing has a true protobuf method or something like that, or I think maybe like a generator thing in JavaScript, you know that that thing abides that contract. And we did not have this in Erlang. And because we did not have that, I thought, hey, the solution for these are objects, right? So I added objects,
Right,
and and then a lot of things they became clunky as a result of that. And then later I figured out, no, I just want the polymorphic part of
right,
objects, and I don't need objects to have that. And that's when I learned how Clojure does things, how Go does things, how Haskell does things. I'm like, okay, I'm going to bring that idea in. I mentioned Clojure, and I think Rich Hickey, he helped me a lot to understand those ideas, because one of the way I think, what is the talk? I'm not sure I'm going to remember the title of the talk. Maybe people in the chat will know, and
mm,
they can comment. But it was really about how you can see things as coupling, and how the coupling, breaking those things apart, brings you benefits. So for example, if you take an object, is by definition coupling behavior and state,
states, yeah,
right? And there are a lot of things that come as consequence of that design. Like, so for example, oh, why you need inheritance is because sometimes you want to extend, because you have to couple the behavior with state, and it comes with its downsides. And then say, well, if you break those things apart, not only you solve problems that were created by a consequence of you putting things together, but you can now express things more naturally, right? There are a bunch of like design patterns that happen in object orientation exactly because of this coupling. Like, oh, what if you just want the behavior? What if you just want the state,
right.
right? And then you start going like you have like now those data classes and those kind of things, because you have to undo the coupling that you did. So his talks, it was have always been like very informative in trying to understand things, and why certain things are advantages, or where are the disadvantages. And yeah, and objects for me, yes, I see them. Not only, it's actually three things. It's not only the coupling of behavior and state, but objects, they are also mutable,
Right.
which means that they change over time. So you have like three dimensions now in this one thing. And that's why sometimes like trying to understand how an object has evolved over time, it gets so complex, because all those things, they are all related to each other. So I remember, for example, like sometime when you would be writing like if you're working like on application, sometimes you have to write a test. And in order for you to test the scenario that you need, you have to call these and these
In
and
the right
these and these
order.
in the
Yeah.
object. Yeah, you have to build the whole history, right? Because all those things, they are coupled. And then you can do the assertion. So yeah, so for me, it's like breaking those things apart and being able to see each of them individually brings a huge amount of clarity to the code, to the point today that you were saying like earlier that you work with Elixir or a functional programming language, you rewire your
Mhm.
brain. And it in some ways it's kind of annoying because when you go back to use a language that, for example, has mutability everywhere, it kind of makes you paranoid. You're
Yeah.
like, wait, you call a method and you're like, wait, will it mutate my things or not? What else can this thing do that I actually don't know about?
Yeah.
Right? So you're kind of like living on the edge. You're
Yeah.
like, what can this thing be doing? And then if you break those things apart, you can reason about them. And I think for the understanding of the software at the end of the day, it is much clearer.
It's interesting because I think people ascribe, I see this all the time where people ascribe certain properties or capabilities to some feature. They're like, oh, if you don't have classes, if you don't have object orientation, you can't do X, Y, and Z. And I actually did a whole stream where I kept asking the chat saying, okay, name something I can't do without classes. And they kept saying stuff, but you can do them because they're not properties of like that exact solution. Like you said, they're actually three separate properties that they exist on their own. And then I was able to show there's all sorts of other stuff you can do that are kind of awkward with like the traditional object-oriented setup. At least in JavaScript, you can't do like multi-inheritance and how like flipping all of this, you can like compose different things together so that this behavior actually inherits like three other things that you find useful. When you use certain abstractions, sometimes you don't really understand what they're providing you or how. You just kind of understand the end feature sets. But yeah, that was another key thing that when I moved to Elixir, it made me writing code in other, because I always had to write JavaScript for the front end. So it made all of my JavaScript code much better because Elixir kind of taught me that like you can do everything with just these simple things.
Just one thing on that, because there is a quote that I like a lot from a book. It's a more like academic technical book.
Mhm.
They start with a programming language. It's principles, concepts, and techniques of programming languages or something like that. And it starts with a programming language that like can't do much, and it slowly add features
Mm.
to it like objects, concurrency. And one of the quotes in that book that I like a lot is that you should always use the simplest abstraction available
Mhm.
to solve your problem. And I think this is very powerful because if you think about objects, it's a very powerful abstraction, exactly because it has those three things,
Yeah.
right? But a lot of the times you could be using just simpler things, right? As
Right.
you're saying, just modules and functions to solve the problem and have the object to be not the default
Right.
solution that you reach into, right? It's like you should reach into that when you need it.
Again, a lot of stuff is just arbitrary. You start working in a language or you start working in a code base with certain patterns that you think are the way to do things, but it turns out you can kind of reduce it a lot. Yeah. So anyway, the other thing I was going to, so we started very low level, just talking about the language. But another great thing that I love about Elixir, which I miss so much, is the amazing standard library. So in the JavaScript world, the standard library is like, it's not very good, I think, especially compared to other languages. It's one, kind of inconsistent internally just because of the years of decisions that have changed. Two, just very incomplete. You have to like reach out for external libraries for basic things. And the thing I always point people to is go look at the enum module in Elixir, go look at the stream module in Elixir. It is such a complete thing. Like almost any like operation you need to do, there's probably something that's helpful there. My friend made a joke that there's probably like a enum.sort by birthdays in there. Like it just like has everything you possibly could ever need. So when designing the standard library, kind of how did you approach that? Like, did you take influence from other places? Like how did you decide what belongs in standard library, what to outsource into external things?
That's a great question. That's a great question. Because we don't have objects,
Mm-hmm.
right? So in Elixir, we have a predefined amount of data types. So we have lists, we have tuples, we have maps, which are like dictionaries or like JavaScript objects, but without the behavior part, just the key value association. We have integers, we have floats, but it's predefined. It's probably about 10 or below 10. So in a way, if you just look at that, the standard library doesn't have to be large because you need to cover that surface. Let's say that's the minimum acceptable, the minimum that I have to do. But we also, of course, you can create your custom structs that, for example, if you want to represent a URL, you can create a custom struct that belongs to the language. So in order to, I think like growing the standard library was somewhat focused on solving certain problems
Hmm.
and expressing certain capabilities. So for example, I mentioned lists and I mentioned maps. Both of those things, they are collections. They can hold different things in
Hmm.
them. And then again, Rich Hickey, he had this whole talk about if you have collections in your programming language, instead of having like 3 or 4 different APIs, right? And then streams, they are collections, but they are lazy.
Hmm.
And we also have ranges, which is like an interval, say it's from 1 to 10. So I could define like 4 different APIs for working with each of those things in like in separate modules, namespaces. But Rich Hickey say, no, you want to have one namespace where you put everything, right? And that namespace can work with all different kinds of collections. They can be lazy, they can be eager. So I was like, okay, that's an important concept. And I want to solve that problem in the language. So we have enums, we have streams,
Hmm.
and we have some data types that are very useful to think about that problem. So it was very like specific to the problem. And then the other one is related to concurrency. So concurrency in the Erlang, I know you know this, but
Yeah,
for
for the audience.
context,
Yeah.
yeah, concurrency in the Erlang virtual machine and in Elixir, it's done by starting processes, and those are not the operating system process. Those are cheap, lightweight threads of execution that exists within the Erlang virtual machine. You can like literally create millions of those. So they're all running at the same time. They're all running concurrently. And those processes, they define like some very basic primitives. So for example, they can send messages between each other. And it doesn't matter if those processes they are in the same node or in different machines in the cluster. That's how we get distribution. But they can only send asynchronous messages to each other. But one of the things that is very common is that you want to send a message to a process and get a reply back. So you need some sort of synchronicity abstraction. So, and Erlang has, they call them behaviors. It has behaviors for something that works like a server that is client response.
Hmm.
So one of the things I was used to say at the time, right, when I was starting with Elixir, I was thinking about this, that like we have like this great environment for working with concurrency, right, or even distribution. But if I want to get like a simple problem, like, so for example, even JavaScript, like imagine that you want to access like 4 URLs at the same time, and you don't want one to block on the other, right? You can compose that using async await something, and then
Yeah.
right, like you do the async, and then you await, and it's very easy. But in Erlang, to do that at the time, it would require like a good amount of like
Right.
boilerplate to do that. Like you would eventually encapsulate that boilerplate and put in your application and reuse it. But then it's like everybody's like reinventing their own boilerplate.
Right.
It's so in Elixir, I was like, okay, I want to have like more specific tools for concurrency as well. So we have like the task module in Elixir, which
Hmm.
people usually really enjoy using, which is about encapsulating those patterns. So it was really focused, I think, like on solving certain problems and like closing the gaps in some areas that the Erlang virtual machine was not solving at the time. So for example, another example, coming from Ericsson, Erlang is, let's say, Swedish technology. And at the beginning, it would handle like Latin 1 characters, the encoding. It would not handle UTF-8. So it was very important.
Mm.
I like to joke, like as a Brazilian person living in Poland and communicating in English, it
Right.
was really important for me to handle UTF-8 encoding really, really well. And so the standard library has the string module that also handles all those corner cases for you of upcasing a string, lower casing, and handle those things that they may be broken in other ecosystems, right? Like when you upcase a string with in my name with the accent, it would
Right.
not do it correctly, for example. So it was that, and then it was like a good core. But Elixir is going to ask you to learn things, right?
Right.
Elixir is a functional programming language. It's a concurrent distributed language. It's a distributed concurrent programming language, distributed programming language. You can create things that are fault tolerant. So, and those things, those for me, they are like non-negotiable properties.
Mm-hmm.
Like that's why the language exists, because those things, they come from Erlang. And because this is a learning process, even though we love it, we may still lose people who cannot go through this learning curve, right? They cannot, for some reason, they cannot go through the process. So I wanted to make sure that the tooling was great, like the initial experience, like when you create your project, everything compiles, you can run the test, everything is built in. Go was a huge influence on that. I think Go was one of the programming languages that said, like, how important tooling is. Tooling was not part of the programming language. It was something that you would install separately. And I think Go was really important in changing that. So we're like, the tooling needs to be great, because in our learning experience, we cannot afford to introduce any like accidental friction, right? Like the frictions that we can solve, we need to solve. So that was the focus on, like, I was thinking about all those things when it comes to the standard library. Today, what I like to say is that, so if you say, I want to add this abstraction to Elixir, I say there are two reasons for adding an abstraction to Elixir. Is because one is that abstraction can have, it will be enhanced, and it will be able to do things if it is part of the language that it would not be possible to do if it was not part of the language. So it has to be justified to be part of the language. And it's really hard to do this, because Elixir was designed to be extensible. Anybody can go and can extend the language. Like the most recent example is that you can today compile Elixir code to run on the GPU. And that's a project that does not, like, it doesn't change the language in any way. It's built on top of the existing abstractions. So that's one of the things. Or it's an abstraction that we need to build the language itself. So today, like, that's kind of the guideline. So we have a very clear process for somebody to say, hey, I want to have like this abstraction in the language. Can I? If you have to fulfill at least one of those roles, and then the core is focused today. We're not trying to. So for example, if you want, like, encode or decode something to JSON, it's not part of the standard library. But we have really great tooling that makes it easy to add that to our project in one line of code, right? But it's not a concern that we want to have within the library. We want to let the ecosystem solve those problems.
That's like a tricky line, right? So this is a frustration that I have in the JavaScript world, where, I mean, the thing you said about tooling shouldn't be something you add on top, because that's like unnecessary friction. I think it's a great way to summarize that. Some of the justification I see for that, though, is people argue that letting the ecosystem solve those things potentially results in better solutions. I think that's good in theory. I think in practice, there's certain base things like package management, like things like that, that when you don't have a really great solution that's built in, it ends up being a fragmented, annoying experience. I think Go kind of went through that as well, right? Because they didn't have like an opinionated way to do package management. Then they eventually did add that in, and there was like 5 or 6 that kind of emerged, and they kind of took the best ideas and they added it in. And additionally, like when some things aren't in the standard library, then there's like multiple options. So let's say the thing you talked about, like all the operations you do on collections, right? The equivalent of that exists in JavaScript as well, but it's spread among like a bunch of different libraries. Some libraries will be, like more functional. Some libraries will be more like class oriented. So the fragmentation is a little painful, but people do argue for the diversity that happens when the ecosystem solve it. I feel like we're not at a good, whatever balance there is, you need to find it at. I don't think we're at a good balance. Like, how do you think about this, like, diversity argument when it comes to things like the package management and stuff like that?
Yeah, so I think you nailed it. It is a trade-off, but I'm not sure if I can come up with like a rule, a precise rule.
Yeah.
But for me, it was like, when it comes to package management, I think like it is clear to me that it is part of the onboarding experience.
Yeah.
JavaScript, for example, it does have other luxuries. For example, like, yeah, like if you want to do something for the browser, you have to learn JavaScript, which means that some of the frictions that we have, because we have to attract people, and then we have to convert to to convince them
Right,
and
right.
make the onboard experience good. It's not necessarily a friction that JavaScript has, because you can tell anybody, like everybody has a browser. You can just tell them like open the console and try it out. So I think in a way it's understandable for them to say, look, we won, like we don't have some frictions here, so it's fine for us to have friction in the package management space, and that's fine for us. Maybe it's a fine trade-off to do it, but I think like, so for example, I do write web applications, and so we have the Phoenix web framework, and we went for a lot of churn, like through the JavaScript too. We went through Brunch, I think Gulp
Yeah.
for a while, and then Webpack, and now like the first time that I'm like really happy is when we migrated to ES build, which just seems to be like stable, very
Yeah.
specific. It's not really focused on like changing things all the time. And I'm now really happy with it. But it does generate traction. And like for me, I think yes, package management is important enough to be worth unification. Maybe you don't want to unify within the first X years to let people try out and explore different approaches.
Right.
But I think the unification is going to is important. And I think like some of the new runtimes, I think they
Yep.
started incorporating more like Dano and Bun.
Yep.
They're like, we are owning this problem, and I think that's a very good sign that like, well, this is probably we explored enough. We are comfortable in the solution,
Yeah.
and we are picking an approach. And if it's really important, at some point needs to happen. We went through this with like releases.
Mm.
So for a while,
Oh, right.
like
Yeah, I do remember that.
yeah, so like in the way that you would deploy Elixir applications would be how you would deploy like JavaScript applications. So you would like say, look, I'm going to run on this thing. It needs to have a node or something. And I'm saying like backend JavaScript application. You need to have node running on that machine, on that environment. You install it separately. You install the dependencies and you run the thing. But I think people coming from languages like Go, which allow you to kind of like, I'll just pack everything into this one thing and ship it. They wanted more streamlined solution for a big chunk of time, like for like 2 years. If you ask an Elixir developer what is like the biggest pain for Elixir applications, they would say it would be deployment.
Mm.
We also have like we have a configuration system that we also took time to figure out how that should work. So for a long period of time, it was seen as like the biggest flaw in Elixir. And then we went to the ecosystem and how they solve those problems. It was clear for us that from feedback from the community that it wasn't a problem worth unifying and provide like a unified experience out of the box, that we decided to bring that into the language.
Yeah, there's phases of like, I mean, this happens in business all the time. There's like the unbundling phase where like there's like a million little solutions for everything, and there's like at some point it's followed by a bundling phase where that gets like consolidated into something unified. So the things you pointed out about the new runtimes, I think, yeah, we might be entering a consolidation phase, hopefully. But yeah, it's like there's just been a lot, like even on the package management side in JavaScript, right? You can use npm, you can use pnpm, you can use yarn, and it on some hand each projects did improve on the previous ones, but the state we're in is in this weird fragmentation. And if someone is new, they're just like, there's always this conversation about, okay, like bring up the project. Wait, do you have npm install? Oh, sorry, do you have pnpm install? And they're like, what is that? And then you have to teach them about that. So those little frictions are hard, even though, and I think you made a good point about everyone's forced to do JavaScript. Like you have to pretty much because you do web stuff. So the bar, I guess, didn't have to be as high to get adoption, and that might reflect why some of the cultural things are there, where we expect very little from the ecosystem and the tooling. So the other thing I wanted to ask about, so now that we're talking about more of the ecosystem stuff, so we started with like the language, kind of moving on to some of the other stuff. Elixir is not just a language; it's a fantastic set of ecosystem projects like Ecto and Phoenix. And so Ecto, just for the audience, it's like how you talk to your database in the JavaScript world. You have things like Prisma or Drizzle, things like that. And then Phoenix is a web framework. So when did those start to emerge? And I know like that was more, I know Chris McCord was very involved in some of those things, but Yeah, like when did that start to emerge as like things you wanted to make sure the ecosystem had?
I was always thinking about the language being extensible,
Hmm.
and I knew it would be used for web because that was my background. That's where I had reach. I knew people, they were coming from Elixir. A lot of them were coming from like Ruby, or from, if I was invited to a conference, it was usually a web related conference,
Mm.
even if it was not about Ruby. So I knew like eventually something would appear. But even early on, when I was trying to validate if the language was extensible, I built like a mini web framework, like Express or Sinatra in Ruby,
Mm.
just to see like, hey, is this thing actually extensible? And to try to dog food what I was building. But people are like, "Are you going to maintain this?" And I'm like, "Hell no, no way." I did my share of like a web framework,
Right.
and I don't plan to start like doing this. I want to explore the ideas. So Acto came first, which was a database driver, and this was from Eric Meadows Johnson. He is
Mm.
the creator of HaxPM, which is the package manager. So he did like an amazing work because the community was at the very beginning. I'm almost sure he was still at university, and he was like, "Oh, we need a package manager." So he built the whole package manager and the whole package manager infrastructure,
Wow.
but because we didn't have something to talk to the database, he built the libraries to talk to the database and
Nice.
the ORM. So it was like, okay, like I'm building everything, and everything that I'm building is this open source thing, right?
Yeah.
And I'm going to build on top of that. And the thing about the web framework, it was really interesting because of the background. There were a lot of projects at the time that were trying to be like Rails for Elixir,
Mm.
or it was trying to be like the Sinatra
Hmm.
for Elixir, and they were exploring those different approaches. But it was really like, Rails for Elixir. And Phoenix was actually, so when Chris McCord, he started with Phoenix, he did not start by having Rails for Elixir. What he
Mm.
actually wanted to do is that he wanted to create like rich interactive applications where you could exchange information with the server and receive it back at any time.
Mm.
And he was trying to do that in Rails, and then it was not working out. Things could not work. It was too complex, could not scale. And then he heard about Elixir, and he decided to solve that problem. And for me, and for me, that's why it worked. He was not trying to bring something to the platform. He was like, "Oh, I want to leverage this platform in the best way possible." The platform was the solution to that problem, and he built Phoenix around that. And that's why today we have things like Live View, because everything was designed from like the rich interactive user experience
Hmm.
angle. And so I remember seeing a presentation. I don't remember if it was on the first or the second Elixir Conf, and I was like immediately sold. I was like, all right, like this is it. And then I got
Mm.
involved in the project. I also see like my job at like making sure. So for example, web was expected. I knew web was going to happen. But for example, other things came out later. For example, Nerves, which is
Yeah, I was gonna bring that up
a
as well.
framework for building, yeah, for building high-end embedded systems. It's not a domain that I'm familiar with, but I see it my responsibility to make sure that they are not blocked, right? Like if they have an issue with the language, they have an issue with the tooling, it's my job to make sure that they can address that and evolve further and not be blocked. So, always trying to get people excited about building new ideas, new domains on top of the language.
Yeah, I mean it's amazing how far it's spread, right? So we talk about that web framing. You mentioned Nerves. Like I remember, so when I was getting really into Elixir, I was like trying to use it in places that was not appropriate, and I was working at a company that did have an IoT device, and I was like, let's put Elixir on it, and we were like doing stuff in Elixir, and it ended up not sticking, and like they had other stuff in Go, so they moved to Go. They initially started in C, so going from C to Go, like much big improvement just for productivity of the team. But then like 6 months later, Nerves came out, and I was like, oh, so I wasn't a complete idiot. I did feel like this makes a lot of sense because like there's all the supervisor stuff. Like there's a bunch of different tasks that need to run on these IoT devices, and you just need to schedule and coordinate them. So it felt like the Elixir primitives made a lot of sense there. And I saw Nerves come out, I was like, okay, I wasn't dumb. This like actually does make sense. And that project has grown so much as well. And it's really like, I don't know, if you probably never imagined that would be a thing, right?
Yeah, no, I would never. If you told me, like, there are a lot of things that we do today. Like, if you get in a time machine and say, "Hey, Elixir would have those things," I'll be like, "Sure,
Yeah.
sure," right? And the story from Nerves is also so cool because they had experience from building embedded systems,
Right.
right? And they were like, "Well, we have this Wi-Fi driver thing, and it crashes all the time because the Wi-Fi disconnects,
Yep.
or because it's like." Driver, C operating system code. And then when they heard about supervisors, which is something that when there is a crash, it restarts itself, they're like, that's what we need. And that's what drove them. And I think at the beginning they were actually Erlang. And then what drove them to Elixir was the tooling.
Mm.
They were like, we had the abstractions, but we also want the tooling. They the tooling and making it fast, to making it easy for you to get started and build something, was something that really resonated with them. But like today, like, yeah, you can write Elixir and it's going to compile to the GPU, and you can get like large machine learning models and run on the GPU, and you can deploy in a cluster and route requests to them. Those are things that, like, starting like the machine learning thing, even if you went like 3 years ago, I would not believe that it would be something that would be happening.
Yeah. Yeah, it is really crazy. It's in every space now. Like no matter what you're doing, there is probably a way to do it with Elixir, and it actually makes sense. You're not forcing it at all. So we talked about the language, we talked about the tooling, we talked about frameworks, but there's also like patterns, right? Like how do you build applications that are maintainable? And in the Phoenix docs, they teach you about bounded context and like domain-driven design and all of that. And that's another thing that's sorely missing from the JavaScript ecosystem. It's kind of like you're on your own to figure that out. There's no like guidance on like building these reliable, maintainable systems. So like where did that come from? How come that was an important piece of
No,
the story?
yeah, it's so curious to hear that, because this was, and maybe it still is in some way, it's a little bit of a, I don't know what it's, I don't want to use the word polemic because it's not really polemic, but it's
Mm-hmm.
something that it leads to questioning if that was the good call.
Mm-hmm.
But for example, like, what I've always tried to do, so going back to the failed prototype, what I learned is that it's not because some other language does it, is that it's going to be a good fit, right? We have to think about, like, what that thing is doing and why, and what are the benefits, and if that thing needs to make sense. But if you think, and so you always have to reason about the process. But even then, like, it's hard to be on guard all the time and not have something slip through, because that's how you always did things. So you
Right.
just continue doing that way because that's how you always did it. So, like, in the first version of Acto, our database thing, we had like we solved some problems that, I think, really elegantly compared to other frameworks. So I love Acto change sets, for example,
Yeah.
which is something that builds how you want to make a change to the database, while all other languages are kind of like doing it implicitly. You mutate the object and that everything is reflected. Acto allows you to build like this whole lineage of like the things that you want to do, and I absolutely love it. But sometimes we'll just add callbacks, for example, and add things that are really just coupled to your data. And it took a while for us, like, to learn those things. And again, especially because all we have is modules and functions, right? So how can you get a structure out of that,
Mm-hmm.
right? And then Phoenix context was a way of saying, okay, we are going to provide like some guidance to you, but so you, when you organize your code, you don't want to just like put everything into a flat namespace and just throw everything out there. That's clear to us. You also don't want like, you don't want to have like the god objects,
Right.
because usually what happens in those systems that you have tables with 200 columns because you're just putting things. So what is the guidance that we can give people to say, hey, you may want to think how those things relate to each other and start organizing them into like distinct contexts. So there was a lot of discussion, and at the beginning we had a concern that this would lead like to a paralysis fear or something like that.
Mm.
Like people, because now you're asking people to like think, right? It's like, hey, you have to think how you want to organize your code. But maybe you are at a point out your project where like, look, I don't care, honestly. I just want to ship this and have this proof of concept ready to show to somebody, right? So there was some friction on that, because like asking people to think is great, but if they don't want to think for whatever reason, that's friction. And it's fine to acknowledge that, yeah, it's fine if you don't want to think about it now, but at some point you may want to. So later we were like, well, if you want to define one context for database table, that's not how you should do. But if you want to do that, it's fine. But you
Right.
have to think about the consequences and telling about design. And that was something that I don't think there was like a unique moment for that to happen. It was really like learning from the mistakes that we've copied, learning from the new things, looking at the programs that we wrote, and trying to learn from that and how we can lead to better code. It was a long process.
Yeah, no, and I think you guys landed at a very good spot, because even to this day, and we struggle with that too, right? It's the same thing. Like, you can make something. We really want to focus on maintainability. Like, code bases last for years. Like, how do we help people achieve that? But that doesn't look great as a first look at what, when you're trying to learn something, it kind of feels overwhelming or like too much. So that balance is tricky. But to this day, and I'm a big proponent of like some of the domain driven design stuff, but if you go and look, like Google that phrase, you'll end up with like a thick book like this that has all of these concepts, and it's like very complicated. So I to this day, I still tell people, here's a link to the Phoenix docs. I know we're not doing Elixir, but just go read the ideas of how they think about these things. It's not too extreme. It's going to be helpful, and you should organize your code in that way. But it still provides like that long-term maintainability thing. And I was like, yeah, don't focus on Elixir part. And the docs aren't even too focused on Elixir, at least the parts where they're explaining the ideas of bounded context. But that's how I tell people to kind of like first like understand these ideas and why they make sense.
Yeah, and we didn't want, you said exactly, like we didn't want to say it was a bounded context, and we didn't want to mention DDD, exactly because then somebody's going to search for DDD, and it's like a really thick book,
Yeah.
right? And that would add to they were like, well, if somebody knows DDD, they'll immediately recognize it.
Right.
So we don't have to tell them, right? But we also don't think that grasping all of the big parts of the DDD should be a day one requirement for you to jump into Phoenix. So we try to distill that.
I'm in the TypeScript world now, so a big thing is the type safety stuff. And I saw that I think you guys just put out like a recent paper on some of the type safety research on Elixir. So Elixir has gotten massive without having like an incredible type safety solution. That's still an area that I think is interesting, and I think you guys have been exploring. So I think just for the audience, like, what's like a summary of like the current state of things, and where do you see potential?
Yeah. So yeah, it's funny because the Stack Overflow survey results came out like 2 days ago, and what is the term that they used? Admire. Like the two most admired languages is Rust, which is like really statically typed, like to the point that memory allocation is guided by a type system. And then the second one is Elixir, which is not a very dynamic language. So that's something else that in Elixir, because we have pattern matching and we have guards, we actually usually know what are the types and the things that we are working with. But it is a dynamic language. So I thought it was very interesting. But for us, like why we are doing this, I think we've like the Elixir team did a good job of listening to the community, like historically. So like back, this is probably now, I mean, 7-8 years ago, like a lot of people, they were wanting for the formatter because the language was started to grow and getting adopted. So now people were working in larger teams, and then you started having like discussions about, hey, what is how you're going to format this, and somebody's like, oh, you should do in this style. And then we had some formatters in the community, and then that was one of the things that we're like, okay, it needs to be unified, because if it's not unified, like you're always going to have the discussion, like somebody in the project is going to want to use this tool or this other tool. You're like, it's going to be unified, very few configuration options for better or worse, and it is what it is. And it's something that, for example, I struggle at the beginning, like with the formatter. right? Like there's like the joke, like the best formatted code is the code that I write, right? Is and then I was pretty much in that camp, and as we're writing the formatter, we were discussing with the team, and then I was looking at my own code, and it was what is the logic for formatting this, and there was actually no logic. It was just like whatever. It's like I think this is better. So it was a hard process, but we were like, we're going to be better because of it. And then deploying. So if you ask the Elixir community today, what is the biggest thing that is missing in the language? They are going to say static typing.
Mhm.
It's like the huge majority. It's not like it's like more than 2/3. So I think I say like I'm not sure if Elixir is going to be statically typed at the end, but I think we have to give a honest try. Like we have to try to do it. I tried to do it like 5 years ago and it
Right.
absolutely sucked, but I'm used with my prototype sucking. And now we are like partnering with a senior researcher on type systems. We have a PhD student because the thing is, usually when you're starting a programming language, right, and you say I want to have types, you design the programming
Right.
language with the type system. And when you are in that scenario, it doesn't apply to TypeScript. But when you are in that scenario, usually the TypeScript, the type system is restricting the language. There are things that you think it would be like, you look at the program, it's like, hey, maybe this should be possible, but the type system is going to be like, no, you can't do that because I can't understand that.
Right.
And languages like Go, they use the type system as a mechanism to restrict the language and make sure that the language is simple, right? But if you have a dynamic language, like there was nothing restricting it. So it has a large expressive power. There's a lot of things that you can do, right? So the challenge is that, well, we need to find now a type system that is going to obey the rules of this
Mhm.
existing language, right? And most likely, you're not going to get 100% fit.
Right.
It's not possible. You're going to have to make trade-offs. And when you don't have this 100% fit, two things are going to happen. One, because the type system does not understand that code, it's going to say, hey, this code is not valid. But if you remove the types, the code runs. But if you
Right.
add the type's like, this code is not valid. I
Yeah.
cannot understand it,
Yeah.
right? So that's one of the things that can happen. But the other thing that can happen is that it can say, oh, I don't understand this code. So what I'm going to do is that I'm going to introduce a dynamic, or in TypeScript, a
Mhm.
any. But every time you introduce the any, it means that you're getting fewer guarantees from the type system, right? So that's the trade-off.
Right.
So what we are doing is that, so we were in a research stage, and we were like, okay, how do we have a type system that can map and understand as much of the Elixir language as possible? So we are working, with the researcher, the PhD student, exactly to do that, and it was really valuable work with them because we were able to get a type system that is based on set theoretic types, and I'm going to talk about it very briefly, that is based on set theoretic types and applied to the language. And in the parts that it did not apply, they actually went and developed new theory. They're like, we can't do that. We are
Nice.
going to develop theory, the mathematical proof that I actually don't understand, and we are going to prove that this is good, so we can incorporate that into the language. So right now we have the formalization of a type system that can express like a really large amount of Elixir idioms and Elixir features.
Yeah.
So that's important. And that's based on set theoretic types. And what that means, it's something is that the type operations, you think about it, everything as set operations, which for me it's really important because set operations, we learn them like early on, right? High school or even before. We think about unions, intersections. It's easy for us to reason when things belong to a set or not.
Right.
So a lot of the things that if you work with type language, like, oh, uh, bounded polymorphism, subtyping, like all those fancy things, for us, it's always going to be, oh, that's asking if something belongs to a set.
Right.
That's the union of two sets. So that's really elegant. So when I learned about this approach, I really enjoyed it. And that's what we did. So we have something that in theory maps really well to Elixir idioms. And we are getting out of the research approach.
Mhm.
We're getting out of the research stage.
Mhm.
And now we are heading to, so that's one very big validation, but will it work in practice? Will it be efficient? So for example, imagine that we had this type system and now Elixir compiles like 2 times slower, 5 times slower. Is that a trade-off that we are comfortable with making? So what we'll do is that we'll start implementing the type system. And because in Elixir, again, you usually know the types that you have because of pattern matching and
Right.
guards. Our goal is to actually leverage this information and feed that into the type system.
Interesting.
So we can start giving you type errors without you declaring any type whatsoever.
Yep.
And this is going to be great because it's going to be, you won't have to change your code. You get feedback. We are going to use this as an opportunity to improve the error messages, make sure the experience is great. We are going to use it as a way to validate the performance. And then if for some reason we are not happy with this initial stage, we will be like, all right, you never had to change the language anyway. So you're just going to get a type system. We are going to throw it out. We gave our honest effort.
Yep.
But if it really works, then we can go to the next stage and tell users, now you can start writing types.
Right.
And so that's what we are doing. It's really like, I think it's really a honest effort in trying to make this work in a way that it feels part of the language, that it doesn't feel fragmented. It doesn't feel like the language becomes like those two different things where one is dynamic and one is static.
Right.
That's what we want to do, but it's still unclear. I always try to temper people's expectations. Like the answer may be no. The answer may be like it's still not doable,
Right.
and we'll try again in 10 years.
Yeah. No, that makes a lot of sense. I mean, thanks for that summary. That's pretty exciting because it's the thing you said about the all the pattern matching code you write. There's just such useful information there, and I think a lot of people think about, especially when they compare it to Rust, right? They think about, oh, a type system isn't useful unless it's like complete or like entirely sound. But what most people are just asking for is like better hints when they're writing the code. And just being able to infer more of that from the code they've already written, like that's already like a huge milestone to, like, as like a first step. And it can only get better from there. So yeah, I think for me, when I desired type safety in Elixir, I just meant like a little bit more than what we have today, and that kind of brings me to a practically like a good place. So I think for me, like inferring from the code you write, that's kind of what I think of when I think about, when I want type safety. I don't necessarily think about like, writing my types first and like doing all the, then writing my implementation from the code, which I do sometimes, but it's not like the default way that I work on things. So yeah, I mean, I'm really excited that you guys are doing that research, and excited to see where that ends up.
Yeah, and I think what exactly what you described, I think it's a common sentiment. A lot of people, they're not like, we want the type system because I wanted to catch 100% of my bugs or something like that, but it's because they're like, we recognize and we appreciate that a type system is going to lead to a better experience. And even though it's not perfect, the better experience is worth it. But we'll try to do both. We'll try to do the correct and good experience, and we'll see where it's going to fall flat.
Yeah. And I think TypeScript has proven like that's like the common sentiment as well, because again, TypeScript is not like 100% correct or sound type system, but the amount of adoption has gotten, people like it despite that, right? So yeah, that does make a lot of sense. Cool. So that's everything I had. Just as like a summary to the audience, the stuff we talked about, there's like a 1 or so hour conversation. We covered a good amount of stuff that exists in the Elixir space. This is still just a tiny, there's still like so much more that we hadn't really covered. I just so strongly recommend that everyone, it doesn't matter if you're going to use it in production, it doesn't matter if it makes sense at your company, go explore it. There's just so many good ideas there that you can learn from that will make the rest of your code better. Just be inspired from like Jose has been talking about, like, the overall ecosystem, the way it all comes together, and the consistency, and just like there's so many places where you can use Elixir. I think that just will change our expectations out of whatever language you're using today. There's a lot of opportunity for inspiration.
Thanks for having me. I really enjoyed it, and everybody have a great weekend.
Yeah,
and see you around.
All right, see ya. Good day.